Can you hear me?
Yes.
Yes.
Okay, thank you. Good afternoon. You're supposed to be attempting this problem here. Now, I note that there's a piece of information that was missing. The diameter of the pipe or the tube. Let's assume that the diameter of the tube to be equals to 0.1 of a meter. Okay. Sorry about that. So the diameter is equal to 0.1 of a meter. Let's just assume that. Now, I've already gone through the kind of maths that you need to look at for this particular tutorial problem. So if you have any questions, please feel free to ask. Otherwise, you should be able to work on this on your own. So like I said, the equation that you need to use for this particular worksheet is, I'll just flash it out in a minute. Remember this set of lectures that we went through yesterday? Not yesterday, last week. Now, these are the equations that you need, okay? The amplitude of the reflection of the standing wave pattern. Now, bearing in mind that A is the amplitude of the pressure fluctuation, okay? So equations like this and the standing wave ratio, this is something which you will need. Is there any questions that you'd like to ask apart from how to do the problem?
I just have just one question. So for the last one, so the amplitude is that just the same as the pressure sound level, which is in dB? Is that just it?
No.
Oh,
no,
okay.
no. Okay. I'll look for the. What's the best thing to do? Let me see. Okay.
So so from the 92 dB, I should work backwards to get the pressure amplitude, like PRMS.
Correct. Yes.
Okay. I see now.
Very good.
Yep.
Very good.
Yep. That's so, and that's all. And then from there, I get R, alpha, and whatnot.
Correct. Just give me a second. I'll just see if I can pull out the. Yep. Okay. Now, if you look at your lecture notes, series A4 1D sound.
Just give me a second.
Yeah, this equation here.
Yeah.
Yeah.
Yep.
So this is your mean square pressure fluctuation.
Oh, I see.
Yeah, that's that's the amplitude.
That's amplitude. Yeah.
Square pressure. You need to use your SPL, okay,
Yeah.
and convert that to the PRMS.
Oh, I see.
Yeah.
So the question. Sorry.
Yeah, go on.
So no, I was just confused with like the terminology then, I think, because so the pressure amplitude is like the amplitude of actual pressure wave, and then the pressure levels is separate, and that's in decibels. And
That's correct. Very
okay.
good.
Okay. Yeah.
Very good.
Okay, yep. I think I got that. Thanks a lot.
All right. So look, if there's any confusion now, you measure your pressure.
Yep.
Yeah. This pressure will be written at the amplitude. This is the equation.
Yep. And that's just pure pressure, like in pascals.
Correct. Now this is in Pascal.
Yep.
And so which means that the RMS will be equals to A on root 2, right?
Oh yeah.
Okay. Now I think I need to admit more people. Just give me a second.
No worries.
Now, the moment you've got that, then I can say that the sound pressure level, now this is still in Pascal, right?
Yep.
So the sound pressure level will be 10 times log of the mean square, okay, over 2 times 10 to the negative 6. And then that will give you a decibel, or better not write that. It's a reference level.
Yeah. No, I hear you.
Yeah. All right.
Mm-hmm.
Sorry, isn't it 20 times 10 to
It's a
yeah. That's why I
yeah, and are both of those terms squared?
hang on, just give.
It's a squared if you do 10 times log because of
correct.
Yeah.
Yes.
That's what I was.
Yeah, that's right. The mean. Yeah. Okay, so this is P reference.
And then square that. Yeah.
Yeah. Okay. So that's the basic. So now you got yours. Now you got your sound. They told you the sound pressure level. You got out this.
Yeah.
Okay. Okay, now I feel bad not being able to see your face to face, but okay, I tell you what I'll do. I'll show you this. Can you all see this? Those people who wants to do it on their own and not want to look at this, just look away. But otherwise, you can have a look at this. All right, so this is what we have. And you need to calculate the wave speed for the temperature. And these are your sound pressure level, okay, that you've measured, your SPL max and the SPL minimum, which means that the standing wave pattern will have SPL max and min like so. All right, and then from there, you'll be able to calculate the RMS value of the pressure maximum and the pressure minimum, and you should be able to then refer this to the amplitude. Okay. All right. So then from there, you'll be able to calculate your standing wave ratio. Now, what is immediately obvious from here, all right, is that you don't just, decibel is just an indication. But if you want because our reflective, or what do you call that? The standing wave ratio. The standing wave ratio is expressed in terms of pressure. All right, and you cannot just simply divide the you can't just use SPL max on SPL min to give you your standing wave ratio, because it's just not right, because this decibel is kind of like a fun unit. Okay, it's not really an absolute unit like Pascal, or a defined unit like Pascal. Okay, if you want to find a standing wave ratio, the way that we define it in the lecture notes, or indeed as a standard, we need the magnitude, not those quantities expressed in terms of the what do you call that, the decibels. Okay, now because we've got almost half the class who are here, so there will be an added bonus. Now, the question also require you to find out. Now, they say that the first minimum is at this point. They want you to find out where is the second minimum. Okay. Now, if you look at the lecture notes, the separation between this must be equals to lambda on 2. So which means that you need to find the wavelengths. Okay. Now, if you look at the solution, that we went through the trouble of defining this quantity. All right, but just bear in mind that for any standing wave, the separation between the maxima, or the corresponding maxima, and the separation between the corresponding minima is always lambda on 2. Okay. So with that, you should be able to do your the problems. If you have any problem, just shout out, and I'm happy to help. All right. I'll just keep quiet from now on. If you want, if you rather chat, I'm happy to chat with you. Okay. So if you want, if you don't want to talk, and if you want to chat with me privately, then that's fine. I'm happy to answer questions on the chat box as well. All right. Okay. The diameter. Just assume that the diameter of the tube to be equals to 0.1 of a meter. Sorry, I should have put that in the question. So assume that the diameter of the tube to be equals to 0.1 of a meter. Good job, Jeff. At least you understood the material. It's great. This is very, very unusual. I have never attended a tutorial class or work this problem solving class where it's so quiet. This is really good. But please don't unmute your mic all of a sudden. All right, just keep it that way. That's all good.
Hi, Wayne, just a question.
Yep.
Just with that little example that you've given us with the standing waveform, the Landeron 2, that's from the maximum to the minimum?
No. It is from the minimum to the minimum.
Okay.
Do you remember the? Hang on, I'll just share this. I think we.
Is that because the wavelength, if it's
There you
like
go.
a sine curve?
Can you see this?
Yeah.
All right.
Right. Okay.
Now, this is all the mathematics that when you get your solutions. When I post out the solution sometime next week or so, you will see the calculations. But for the purpose of this exercise, just recognize that the separation is landed on 2. Yeah. You have a question about the lab?
Yeah, hi. So for today's lab at from 3 to 4, so it's the only lab which is due and we need to write a report, and the rest 2 lab is like we just need to write 40 lines on the Moodle quiz.
Okay. Okay. Yep. Good question. I'll just share this screen. Now, as far as the lab report is not supposed to be too long. Okay. Now, there's only one report to be submitted. And that is the one that is known as the transmission loss lab. Okay.
Yes.
Now, in this transmission loss lab, the readings are already given to you. If you want to do your own measurement, that's fine, but the readings are all given. Okay. So as far as the reporting is concerned, you need to submit the report within a week. And in the report, you just submit it via the Moodle. Okay. Now, in Moodle, you will see places where you can put your text. Now, this is where you should only cut and paste your text. I don't think this thing can accommodate figures.
Okay.
All right. So just put your text here. But any figures, please convert them to a PDF file, and then you can upload it. Okay, there's a space. It looks like this is where you put your text, and then there's a space at the bottom here where it says you can download your or you can upload your PDF file. Okay.
Yeah. Yeah.
So please, I have deliberately limited the number of lines in this text box. There's no need to put lots and lots of just be clear and concise. Okay, so if you have calculated the transmission loss, you can what I would really require you to do is to first of all is to describe the room, or in this case your fictitious describe the room that you're in. Okay, but you will assume the noise recording. Okay.
Yeah.
And the important thing is the absorption. Now, when you describe your room, you will need to talk about things like there's been carpeted or with floorboards. Like how much furniture it has, or whether or not there's people, because all this will affect the absorption coefficient of the absorption characteristic of the room. Okay, so in your report, it'll be good to highlight some of this stuff and then report on the transmission loss. Okay.
Yes.
Look, the thing is, when you do especially 1 and 2, I mean that point 3 is something which we will be going through later on in the semester, where you calculate transmission loss. But 1 and 2, this is where a lot of the qualitative engineering actually takes place, because you need to with your eyes have a look at and observe what are how the room or the place is being constructed, and then from there you'll be able to have a reasonable estimation of what the absorption characteristic is of that of the place that you're measuring. All right. So when we come to this part of the course, hopefully the stuff that you did in the lab and the things that you've reported will make a lot more sense then. Okay? Don't make it big.
When can I just ask a question on that? It says in the lab manual to take 20 measurements in each of the rooms. However, the lab manual just has 10 measurements in each room.
Okay. Now, the number of averages really is dependent on it depends on the size of the room. In a normal motel room that I've done measurements on, I only take about six readings. Okay, but I know that in the manual we say 20, but that could be for a larger size room. But if you're doing any noise measurement yourself, okay, as long as your points are not, it is not like 4 or 5 meters apart, 1 to 2 meters apart, that is okay. And what people normally do is, really when we have noise in the room, and especially a steady sound, we will just move around and make sure that there's not much variation. And if there's not too much variation, then we'll probably take about 3 or 4 points. That's what you do practically. But if there's significant variations, then you will have to take a lot more points. Obviously, if the room is large, then you will have to do correspondingly many measurements. But for the purpose of the lab, look, if you do 10 points, you'll find that those points will actually be quite close to one another. And when you do your average, it won't make too much of a difference. Okay.
So with this, with the provided measured values, do you suggest we just use those?
Yes, you can use the provide. Okay. I do not want to put too much pressure on you guys. Okay. If you want, because it is impossible. In the previous years, we have groups of 10 people, and they'll go to one establishment, and then they will do the measurements at the establishment. Because we are all socially isolated, I don't want you to have to run around and do the measurement in the source room and in the receiver room. Yeah, look, unless you're happy to do so, but I'm not going to put that on you. Okay, which is why I gave you the assumed sound pressure level in the source room and in the receiver room.
Okay. All right.
All right.
Yeah.
Yeah, but look, if you really want to do the experiment and have a look at it for yourself, okay. What I suggest that you do is, within reasons, create some noise here, okay. And then just take one measurement here and one measurement there, just as an indication. And if it is at all possible, leave some air gaps between this partition, and you do the measurement again, and you will see that there will be a huge difference in transmission loss when there's some gaps.
What about, so with, I'm just going to annotate on your drawing. So if in my house, there's like a hallway here, and say this is my room, and then there's the other bedroom here is this whole area. So there's a door here and a door here. And it's kind of the same with all the rooms in my house. There's no, like door just from here to here.
Yeah, fine. Look,
that's okay.
If I were you, and if you're interested in doing some investigation, this is what I would do. Let's just say that you are the complainant, all right? Say you're here. This is your this is where you are.
Yeah.
So you're the receiver. What I would do is, and this is a doorway, right? You said.
Yeah.
And your bedroom door is here.
Yeah.
if it is at all possible, I will play a white noise over here,
Mm-hmm.
right? It has to be sufficiently large, loud enough there. So you do one SPL here, and then you do one SPL at one location, given location,
Yeah.
with all these doors closed, all right?
Mm-hmm.
And with your door open, and then with this door closed, and then with this door open, and with this door open,
Yeah.
and with this door open, and with your door closed. So you have about four different scenarios, yeah?
Mm-hmm.
And you should be able to appreciate what is the difference in the noise level.
Okay. And that white noise, I just play off the phone, off an app or something.
Yeah, you can do that, but not too long ago we still have radios.
Yeah. Also, any radio noise is white noise.
No. Well, maybe 3AW is. If you tune the radio in between station,
Yeah.
okay, in between station where you have lots of static,
Yeah.
yeah, that is kind of white noise. It's not quite, but that should be good enough.
Okay. Okay. So mostly between AM channels.
I would say so, but I think now with if you come to our generation, okay, we have this thing called iPhones and stuff, right?
Yeah.
Yeah. So I think with this, they should have and you should be able to download some white noise.
Yeah.
And that would actually be better. So play it from your laptop, which is a much more powerful noise source, and then you should be able to get an idea of what those things will look like.
Okay.
The transmission loss.
Yeah. Okay.
Okay.
Thanks, Wing.
No problem.
Excuse me.
Yeah.
I want to know what's the duration of processing report. So I just attempt to the noise measurement report incidentally. So
1 week. Just put it in. Look, I'm not. Yeah. Look, as long as you put the report in within a week, that's fine.
it just I didn't do this report. So I just click the attempt, and then I attempt to the report. So the state of the report is in progress. So I don't know.
Finish it and submit it. I didn't put any time limit on the. There's no timer on the. So you can just click anytime.
Okay. Yeah. Thank you. And
Okay.
I want and for the transmission loss report, I have transmitted the Word document. So is that okay?
Yeah, if you just upload it in the respective text box, the respective places in the Moodle response that I've set up, that should be good. Convert to
Okay.
PDF and just upload it.
No. Yeah. I just I have done this yesterday. I upload the Word files. Yeah. So is that fine?
Yeah, that's fine. That's fine.
It's not PDF.
I saw a few. No, PDF. I actually allow it to accept all file formats, but if it is Word document, is okay.
Okay. Thank you very much.
Okay, thank you. Now, talking about the noise, the laboratory, I think we we have another lab which is known as noise measurement. Yeah. Now, that is I'm not suggesting that I mean, again, this lab there's no report required, okay? But this is something which, if you guys are curious, this is a very, very topical type of noise measurements that people actually do, okay? Well, now that we are in stage 4 lockdown, it may not be quite so different, but if you, because you're at home, and if you're in your room, okay, using your Android device or your iPhone, you know, we want you to download a sound pressure sound level meter. What I would do is, over a 5-minute interval, and that's what the lab you're supposed to do. You measure the noise, take the average noise during the daytime, okay, night and evening time. Day meaning from 7 a.m. to 6 p.m. And then in the evening is 6 to 8 p.m. And then night is 8 p.m. right up to 7 a.m. the next morning. Now, in the same location, and when you do your 5-minute interval in this 3 different time period, you should see a difference in your sound pressure level. And during your measurement, and if you take note of the types of noise, okay, it is actually very informative, because if you look at, if you go Google into noise reports, there are lots and lots of reports on the environmental noise. Okay, environmental noise from any heavy industry, and you'll find that this kind of measurement is often done. All right, so what we want you, or what I want you to do in the lab may look like a very mundane type of a task, but you know, if you look into some of these sites, you'll see the practicality associated with that particular lab. And I hope that you'll be able to appreciate why things are done the way that they are done. And later on in this semester, we'll be talking about environmental noise assessment. And yeah, you'll also be required to do an assignment on the use of set number 1 for noise assessment. Okay.
Eileen, could I just confirm something for this week's quiz?
Yep.
I think I'm getting a bit confused. With this, so this amplitude max,
Yeah.
can we use that as the like 92 decibels that's given in the question, or is that in terms of pressure?
This should be pressure. If you look at this quantity here, A is the amplitude of the pressure fluctuation. Remember?
Yeah.
Okay, so this A here is so which means that this has to be pressure. It's not decibel.
Yeah. So when we use so that A is from the equation like P dash equals A cos W.
Correct. Yes.
Plus
Yes.
AX and minus KX. But what's this? Where are we getting this? That amplitude max.
Okay. Now, this is where the amplitude max is, right?
Yeah.
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 This amplitude max is the SPL max. All right. Now, this sound pressure level, because the sound pressure level is defined as 20 log PRMS on P reference, remember?
Yeah.
Okay, and the PRMS, or this pressure is equals to A cosine omega T minus KX, remember?
Yeah. That's PRMS is equal to that.
No, if like the PRMS, that which means that the RMS value must be equals to A on root 2.
Okay. Yeah.
So this A is that A.
Yeah. Okay. That makes sense. Cool. Yeah. Thank you.
All right, good. All right. So if is there any other questions? If not, I have to go to another tutorial. So thank you so much for staying. I appreciate your presence. I hope, yep. I'll see you later this afternoon. Thank you. Thank you. Thank you.